Yes, so one of the most challenging parts is the actuation and automation parts in this assignment. Well, actually, all three of the parts, they are challenging, but for people who haven't been doing any Arduino coding or too much programming at all, so this might be challenging. So in order to drive our motors, we need a driver, and so we need like a certain computer intelligence. So we need a microcontroller that is able to receive messages and then interpret these messages and then convert them into electrical signals in order to drive the motors. So the board over here, so this one, and it is connected to this mechanism over here. So this is a 2-axis machine that was built by Elliott last year. And what we want to achieve with this is that we want to be able to move it like this. In one way or another, your machines are going to be similar. Yeah, and like in order to make this work, you need to configure the board here in order to be able to accept messages from the computer. And this is where GRBL comes in. So GRBL is a library for Arduino, which effectively transforms an Arduino to a motion control device. And this is so it used to be under GRBL repository on GitHub, but the new repository is here. So you need to go to GitHub, GNEA/GRBL. And here it lives. And usually these repositories have releases, and in order to download the latest release, you click on the release tag, and you scroll down to artifacts, and then you should download the source code, unless you know how to deal with the hex files. Then when you download the source code, it's going to be as a zip file. It's going to contain this folder, and within this folder, it's going to be the whole repository. And what you need for Arduino is only this directory. So it's where all the files live, and you have to extract it to a place on your computer where you have your Arduino libraries. In my case, it is home Arduino libraries, and I have it here already. And then in order to upload it, you need to open your Arduino IDE and should be able to see it here. So on the bottom of this list, there should be a GRBL example. And you need to select the GRBL upload example, and which includes this GRBL-H library. And then before uploading, you need to make sure that you are using the Arduino Uno board. And for the port, you can select this Arduino Uno port. And then you can hit upload in order to upload it to the Arduino. So just verify, just to make sure that it compiles and it doesn't give you any errors. There's a warning about low memory, just because it's designed to fit exactly in the memory. So, and from this point, you should be able to communicate with the Arduino by using the serial monitor. And you need to select this baud rate as the default one, because it's also, when you read the GRBL documentation, this is going to be mentioned there. And once you open up this serial monitor, you'll see that the board replies you with a message. And here you can actually send messages to it in order to find out more about what commands and what messages you can send to it. And if you type 2 of these dollar letters, you will see it will reply with a list of parameters, which are basically numbers, but you can find the meanings of these numbers in the documentation. In the documentation, meaning that if you go to the main page of the GRBL library, you can click on the wiki over here. And so these sections over here, they pretty much cover everything you can know about GRBL from a user's perspective. If you want to know more, then you can just dive into the code itself. But the configuration parameters that we just saw can be found here. So you can configure your GRBL board so that it fits your exact mechanism. So in here, the most important parts are the steps per millimeter. And so some of, I think most of us, we are working, all groups we are working with a rotary axis. And so you might ask, why, how to translate millimeters to degrees for rotation. And the solution is actually very simple. So wherever you see millimeters, you just put degrees there. So you can define degrees as stepper motor steps. So a stepper motor is a mechanism. So it's from magnets and electrical coils. A stepper motor usually has 2 phases, and these phases are activated one after each other, so that the magnets can turn a certain amount of steps, or more or less like this. The motion happens step by step. So, which makes it very, very nice for precision motion. And also each stepper motor has a certain amount of steps, that let them complete the full revolution. So, and it's not necessarily matching the degrees. So it's not necessarily 360 steps. So in this case, and in most cases, it's 200 steps, which means that one step is 1.8 degrees. And this is where the parameters come in. So you can define how many steps mean how to be translated as one certain unit. So if you're using a linear axis, then a millimeter could be 250 stepper motor steps. But if you are using a rotary axis, then it might be some different unit. But it also depends on what is the mechanical translation. So maybe on the motor, you have a bigger gear. And here also I have some marks over here. So this means 2 centimeters. And I'm gonna show you how you can set these by using a universal G-code sender. Controlling the board with Arduino serial line, it's one way, so to test certain things. But more sophisticated way might be by using a universal G-code sender. So here, when you go to the GRBL wiki page, then you can open the using GRBL page, and so it has a nice introduction into how things work with GRBL. And there are some links to G-code streaming programs that you can use. So I chose to use the universal G-code sender, but there are several you could, you're encouraged to try out. So there's probably a reason why this one is listed as first. But yeah, there's universal G-code sender, ultimate CNC, easel, like these. So, but yeah, I chose to go with the universal G-code sender. It's a repository as this, and in order to get a compiled version, you should go to releases, to latest release. And here you can see all the platforms. You can download it according to your platform. So on Linux, I need to open terminal in the directory. I'm going to list it, and I need to open the UGS platform executable like this. And here we have it open. And on the top side, you can see connection properties. And you should connect to a certain port. Oh, there's some, and you can detect the port by clicking this refresh button. So if you have several Arduinos or board connected, then you might have multiple serial ports available. And you also need to specify the baud rate. So there's a list of popular baud rates over here. And yeah, it supports also different firmwares. So GRBL is also like one way from several that you can use with your motors and boards. And then you hit connect, and it should connect to the board. If the connection is successful, then you should see these OK messages over here. Then you can use the jog control in order to see whether it moves or not. So here you can set how many millimeters you want to move. You can specify the step size for Z, but we have nothing connected to the Z axis, so it doesn't make sense. So you just need to set the step size along the X and Y axis. And feed rate, this is going to be millimeters per minute, I suppose. It's not defined here, but it's usually millimeters per minute, or any other units that you choose per minute. So if you are working with rotation, then it's going to be angles, so degrees per minute and so on. And then you send messages like this. So it's going to effectively show you what is the current location of the axes. And then you can also send commands here. So basically you can use this as a reference. So you can, whenever you click a button, it's going to also visualize what message is being sent. And here it's like a combination of messages. So this F200 means that it's setting the feed rate to 200. Then this G91 means that it's moving the axis, and so G21 means that it's moving the axis. And then G91 probably means that it's getting the value of an axis, so which is x-axis, and subtracting it by 20. But let's see, let's try to actually copy this. And -5 is going to move. So I would like to show this side by side. So you can use these commands individually to do things. And this is like getting the existing value of the axis and subtracting 5 millimeters or 5 units, if you wish. And if you're building an interface, then you can use these commands. So you can use this G-code sending interface in order to get an impression, or in order to find out what are the exact commands that are being sent to the machine, in order for you to take this and replace the values. So yeah, I wanted to show how the axis moves. So now I'm going to click the X minus and X plus by 20 millimeters. And then the way how you can set the steps per millimeter is that you can add marks. So let's say I'm going to add a mark here. And then I'm going to use a caliper, measure 20 millimeters over here. Let's say 50 in this case. So this could be done in a more precise manner, but just for a demonstration. Now I'm gonna set, I want to go 50 millimeters forward. So I'm gonna set the step size to 50 millimeters. I'm gonna hit X plus. Oh no, it's moving the camera. It goes farther. So I'm gonna hit X minus to move it back. And yeah, so since he moved, since it moved a bit more ahead, it means that we need to decrease the amount of steps per millimeter. So in order to find out the existing value, I'm gonna enter the, in order to find out the existing values, I'm gonna use these double $ marks. And here I see that for 100 steps, this 100 means that it's the parameter. It's the parameter, and then for 1 millimeter, we have 61 steps. So since it moved a little bit behind, so it means that we could reduce the number of steps so that it matches our scenario a bit better. So I'm just gonna copy this, enter it here, and I'm gonna set this to 55 and hit enter. And the GRBL board is gonna respond to me that it's okay. So that this parameter has been set to 55. And now here, I'm gonna repeat the same thing. So I'm gonna hit X plus. So we want to go forward. So I hit X plus and see whether it's gonna arrive at the location that we expect. So it still goes quite a bit over. So I'm gonna move it back with X minus. So let's try to decrease it still, move back to the location that I was predicting. So let's set it to 45. Hit enter. I'm gonna click this X plus button, but first I'm gonna, okay, so I'm gonna click the X plus. Still goes a bit behind. Okay, I'm gonna also increase the feed rates to, let's say, 400, and still gonna decrease the value to 40 steps and X plus. Yeah, almost. So I think we just need to decrease it still a little bit, and we're gonna match the exact measurement that we need. So this is like eyeballing. But of course, you could calculate it quite precisely by knowing what timing belts are you using, and so on, how many gears, how many teeth on your gears you have. But yeah, but let's just try to get it right. So I'm gonna set it to 37 and try again, and maybe increase this to 600. Again, X plus. Nice. That's precise. Okay, I think we can stop here. And yeah, so that's how you control the motor. Then there are a few challenges how you get it working with an interface. So in order to get it working with an interface, so you need a backend and a front-end application. So you could make a front-end application or a web app or native application that contains the interface, but then it has to connect to some sort of a backend that is able to connect to the serial port of your computer in order to send messages to the motherboard. And in the GRBL library, you can go to doc and script. You'll see that there are some example files over here written in Python, which uses the serial and time library. And what the example does is basically establishes a serial connection with a device that you specify. So you have to find out which serial device your board is using. So which serial device your operating system is assigning to the actual motherboard. You can ignore this part. So here, what happens is that Python is reading in a G-code file, and then it is using the serial line, so which is effectively stored in the S variable, and it's sending a few new lines to the GRBL board and waiting for a few seconds. And then flushing the startup text in serial input. So it's basically reading in whatever the board was replying. I'm basically deleting it from the buffer. I think nothing happens here. And then here with the for loop, every line of the file is being read and stored in a variable L. So all the white space and new lines before and at the end of the G-code command is being stripped. Then you get a printout that this line is being sent to the serial line, and then through the S variable and with the right function, so the line is actually being sent to the motor controller, and the new line is being at the end of it. So because GRBL expects new line to be sent after each command, and then once it gets a new line, it knows that the command has to be interpreted somehow. And then here we are reading the output. So GRBL board is sending us like a status, so what is going on. And then I'm printing out, so the Python is printing the output out in front of our eyes in the terminal. And then this goes on for each of the lines. And let's say that the G code is containing a toolpath, and then this is how the axes are being controlled. And you can use this code, this example code, with a software library that is called Python Flask, which is a library that allows you to build APIs, or more like web APIs. And you can go to the user's guide and quick start section to see how to make use of it. So of course you need to cover the installation section first, but this is a guide how to make a minimal application with Flask. And how it works is that it basically, so here you have to use the import statement. So you have to import the Flask library, and then you create an app with the app variable. So you initialize Flask application in this way. And then you use this syntax in order to define endpoints, which are going to be tied together with a specific function. So let's do a little demonstration here. So here I have my terminal. I'm going to go to desktop to demos, and I'm going to create a new directory Flask and create a file, server PY, and open it up in Nano and copy and paste this in here. Now, if I run it in Python 3, it doesn't do anything. I need to export this thing first. Okay, and here we have a server running on the local loopback address. And if we open this up in the browser, we have a hello world over here. Should we take a look at the code? I'm gonna stop this now. That's pretty much what we were expecting. If I changed this to something else. It's gonna be something else. And then what else we can do is that we can use the same syntax in order to define different endpoints. So for example, or let's say move. Let's save this and then run the app, go to the browser and add this at the end. And notice if I try anything else, I'm gonna get a not found message. So when I open the root of the page, I'm still gonna have the hello world. And then when we add the specified endpoint, we're gonna get the message or the output that we are expecting. So how to use this with GRBL. So what you need to do is you need to use the code from the GRBL library, so this one, and copy some parts of it into this server application. So starting from the imports, so we want to import the serial library and we want to import the time library. Then we want to open up the serial line, so which we are then doing before anything else actually. So I'm really gonna keep these together, but I'm gonna, yeah. So the sequence is important. So whenever you start this, the Flask server, it's first gonna initialize the server. And then we want to open the serial line. And we need to replace this with whatever our serial line is. So I'm gonna close this. I'm gonna open the G-code sender. Where do I have it? And here I can see that the serial line that we are using is the TTY ICM1. So this is pretty much what we need to use. So we need to replace this with the correct name. And on top of that, so we're not gonna read GRBL code, but we're gonna wake it up. So I'm gonna copy these lines. Also, this is happening before we are initializing any of the endpoints. And then instead of looping for every line, so I'm gonna just copy these 4 lines and convert them So I'm going to copy them into the move function. So, and instead of printing, wait, so did something too much over here. So the main thing that I need here is this s.write part. And instead of L, we're gonna actually send a G-code command. And I'm going to go back to this universal G-code sender and just copy one of the commands. So let's say Yeah, this one. So why not? And then close this down. Run the app. And there is something wrong. No module name serial. PySerial. Yeah. So pip3 install. Okay, that's done. Okay, next challenge, how to encode this to bytes. Okay, we need to use encode. I assume that we need to use this the same also here. Yeah, so now I go here, we hit move. It gives me an error. Oh yeah, so it's I didn't encode the new line. So what we will do, we'll create a variable G-code, and we can copy this and make a command and plus. So I'm leaving this plus here because just to demonstrate that you can combine strings in Python like this. And then we can use the G-code variable to encode it to bytes and then send it through the serial line. So let's see. Yeah, and it actually moves the axis. And we can go even further and convert this to move forward. Make a new function to move it backward. So these names do not have to be the same, but maybe just to make things easier to understand, I'm going to leave them the same. I'm going to copy this. And instead of -50, I'm going to use plus. So here, so this G means jogging. And then, so it accepts a number of parameters like G21, G91. So these are two different commands. And X, so this reads the existing value from the X-axis and then adds 50 on top of that. And then F means the feed rate. So it's 60 millimeters per minute. And then we can basically repeat the sending and return. The only downside is that you need to wait till the motion actually stops. Yeah, at this point, I'm gonna go to the move forward address. So see, this is the address, hit enter, and the thing moves. And then I'm gonna change this to back. And it's gonna move back. So I'm not going to cover how to build the interface. So here, because it's a bit out of the scope, but it's just gonna be a bit too long. But if you're interested, you can go to the Alto Fab Lab YouTube channel. And if you open up videos, then yeah, so there's a video about building web interface with Riot.js, which shows a way how you can use a Python interface, a Riot.js interface, and a Python backend in order to trigger LEDs on a Raspberry Pi. So yeah, so that's it for today. I hope that this was clarifying some things a little bit. And if you have questions, please do ask.